the basics of how we move all of these requests and responses around the internet, we can actually take a look into that black box and maybe describe a little bit about what it's doing inside. So from here, if we think about this, kind of the first problem we're going to run into is the amount of traffic we have to serve across all of these different applications. So something like Amazon.com, if I go back, the stats that I have are from November 2021. That gets about 3.13 billion visits every month. So that's quite a lot of visits, and you have to think that each one of these visits is going to involve a lot of different requests, several different pages. People tend to not just go to Amazon.com and stop there. They tend to click around a little bit. So each one of these visits could generate several different page requests. So even if this was just one page request, this is 4.3 million page requests per hour. That's 72,000 per minute, and that's 1,200 requests per second. And again, all of that is assuming that just a visitor is opening the page and then not doing anything else. But it actually gets quite a bit more complicated than that, because we already said an HTML page is going to have all of these other things that it's going to reference. So there are going to be images, and there are going to be script files, there are going to be CSS files, there's going to be a lot of things that we're accessing there. So this 72,000 per minute is actually probably quite a few more requests than that. So it's kind of an overwhelming and staggering amount of traffic on some of these big websites on the internet. So the way that this is actually going to be serviced is not by just one single machine. A lot of times you think of a web page as being just one server out there that's running all of these requests and handling all of these requests and generating responses. But what we actually end up being is many, 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 many machines. So there's usually a lot of machines that are involved in serving this type of traffic. We have a lot of different machines because there's too much volume to handle on just one single computer. So we actually have a couple of ways to balance this. One of those ways is DNS balancing, where basically when you go out to a DNS system, a DNS server, it's going to send you to different IP addresses so that we don't even have to go to the same servers. If we cycle through a dozen different IP addresses, we can kind of split the load into 12 different pieces. So randomly moving requests around to different actual IP addresses, routing to different servers, that can be very helpful in trying to reduce the load on the systems. Then we also have load balancing. So load balancing is where we take one of these requests from an IP address and we actually send that out to different servers in order to spread that load out. So if a request takes the machine, say second or 500 milliseconds to respond, if it's getting more than two requests at 500 milliseconds, if it's getting more than two requests a second, it's actually going to get overwhelmed very quickly. So load balancing will allow us to kind of spread that out so that we don't get overwhelmed and that our servers can continue to serve traffic and keep up with these requests. So if we go inside this black box, if we have a really simple diagram, this is as basic as it gets. We send an HTTP request into the black box. It's going to give us an HTTP response back. So there's a couple of different things that might be happening inside of the black box here. One of them is static versus dynamic. So static serving is, if you go back to the early days of the internet in the 1990s, a lot of files were just statically served. It was just a file that existed on the file system, and when someone requested it, the web server that was running would look in that particular folder where the web traffic was supposed to go, and it would just pick that file up right off of the file system and send it back. So static serving is just sending plain old files in response to a request. And this is actually still pretty common. If you think of all of the different things that you might load into your browser that don't change that frequently like JavaScript files or images or style sheets, all of these are going to probably be statically served. And that's going to give us some key advantages that we'll get into later. But basically, that means that these aren't changing. They don't have to be dynamically produced on every request. But if you're used to going to Amazon.com, you'll notice that when you go to Amazon.com, it's going to greet you, it's going to have your name, it's going to have some special or some products that you might be interested in purchasing. And this is dynamic serving. It's basically building a new response specifically for your request. So every time a dynamic response is generated, it's going to be different based on that particular request. So this is going to obviously take up quite a bit more computing power, which is one of the reasons why we might need some of that load balancing that we've already discussed. Now, we also have web servers versus application servers while we're thinking about this. And if we think about a web server, way back, probably 30 years ago, web servers basically just took requests and then they would take something off of the file system, very statically serving the files that are out there. But then, not too far into the 90s, people started thinking about application servers. Basically, this idea that you could take a request and then you could execute some kind of script to generate this content dynamically. So this became these sort of scripts became bigger and bigger and bigger and more complex, to the point where entire frameworks were built for servers. And entire systems. In fact, Java 2 Enterprise Edition is basically an entire set of classes and libraries that is built simply to build more complex dynamic requests or dynamic responses, using data and using a lot of other things to generate that particular response. So we also have things that are online processed versus batch processed. And this is kind of an important concept because, sometimes it's more effective or more efficient to generate a whole lot of data before someone even requests it. So some things that we might do, we can process those online. So for example, if we need to just request a user's, basic information, maybe that's one call to a database or some other data store. And that allows us to make that request and then, quickly access that data and return it. But batch processing sometimes allows you to compute a lot of things before you actually make that request. So one example you might have is, if you have a machine learning prediction, for example, on Amazon, they may have machine learning, or they might utilize machine learning to generate a bunch of suggestions for products that you might be interested in buying. It might actually not be efficient to make those requests individually to the machine learning model each time an HTTP request comes into their server. So they might actually generate all of those for all users who are likely to access the site, and that way when you access them, it's just simple data access. It's not actually going into any type of machine learning model or doing anything more complex. Though machine learning models have gotten pretty quick with predictions, sometimes you want to have things available and ready so that it's already computed. You're capable of accessing it on the server extremely quickly. So online processing computes information as it's requested. Your batch processing is going to have it already processed, already computed, and stored, ready for quick retrieval when a user needs it. Now, we also are going to access databases or other data storage systems. So typically when we talk about databases, we're talking about a relational database management system, something like PostgreSQL or MySQL or Oracle, SQL Server. There's about a dozen really popular relational database systems. And these can be really effective because they do provide a lot of advantages. And we're going to talk a little bit about data storage concepts later in the semester. But databases for a long time were kind of the most straightforward and the most common way that we would access data on the internet for our websites. But nowadays we also have sort of NoSQL data storage systems. These allow us to avoid some of the overhead necessary in databases so that we can be a little bit more nimble, or we can have a particular type of application that can access things very quickly. So one of the things that's really nice about databases is they're very consistent. They're very deterministic in the way that they provide information, but sometimes you don't really care about that level of consistency. For example, if you're looking at a video on YouTube, you probably don't care if it has 32,764,311 views or maybe 3 more views than that. That kind of detail is probably not very useful. So NoSQL may allow you to come up with an answer there that is approximately correct, or close to consistently correct, in a situation where that perfect correctness is maybe not so important. So we do see variety of uses for each one of these nowadays, and I think that we'll talk a little bit more about those systems a little bit later in the term. So you can see here, from a load balancer, we may send things out to any number of application servers. Here we're actually looking at a couple of application servers. So requests will come into the load balancer. Maybe that will go out to a couple of different servers in a farm, and then we might actually access some particular type of database or some particular type of data storage. Typically, when you see data in any type of diagram like this, it's going to be represented by a cylinder. I don't know. It's just the way it always is. Maybe maybe you put data in cans. I'm not sure. I'm not exactly sure how that came to be. Then we might access other systems. We might have machine learning systems, or we might have other data or information systems that we're using. Maybe there's some type of security. Maybe there's something that we're doing for access, but we have other systems that might be used in this application server to create this HTTP response, generate that, and send that back to the user. So this kind of walks you through each one of the pieces necessary to create one of these responses. We're going to, throughout the semester, we're going to build some of the data access. We're going to work on some of the data management, data modeling. We may also get into some of these other servers that you might access. Now, you don't have to worry too much about load balancing in App Engine because it's all handled for you, so you don't have to think too hard about that piece. But for now, hopefully this was a good and useful overview of how you can actually build responses within a server or within a larger server farm or a server system, yeah, we'll keep going further into the topic this semester. Thank you for watching.